First, let us draw the right triangle on the circle. So the x-coordinate will be the adjacent or the base of the triangle, and root 3 would be the opposite or the height of the triangle. Now we need to find the angle POQ, let that be some x degrees. So if you apply tan x equals root 3 over 1 in Desmos, you get x as 60 degrees. Now to convert into radians, let us multiply by pi over 180 degrees. But now we have a 2 in the numerator. So let us divide numerator and denominator by 30. So we get 30 times 2 and 30 times 6. So that will be 2 pi over 6. So m has to be a value 6. All you need to remember is the basics. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. The special right triangles will help us get through the calculations quickly. So whenever you have a 45, 45, 90 triangle, the ratio of the sides would be 1, 1, root 2. And when it is a 30, 60, 90 triangle, the ratio would be 1 is to root 3 is to 2. So from these ratios itself, we get sine 30 is 1 over 2 and sine 60 is root 3 over 2 and sine 45 will be 1 over root 2. Sometimes we may have to apply these identities. So sine square theta plus cos square theta is 1. Tan is the division of sine and cosine. And these are very important. Sine 90 minus theta is cosine theta, and cosine 90 minus theta also will be sine theta. There have been many questions based on this identity. And unit circle, just sketch the right triangle first. The hypotenuse will be the distance from origin. Adjacent will be x, opposite will be y. And always remember, pi radians is 180 degrees, and it is also equal to a value 3.14. Now, in the quadrant plane, we know it starts from 0 degrees, and the right angle is 90 degrees. And then we have 180 degrees, and then the 270 degrees. Now, when you repeat it in a cycle, 0 degrees now again is same as 360 degrees. So 0 and 2 pi both are equivalent. Similarly, pi by 2, 3 by pi by 2 are all equivalent angles. Similarly, pi, 3 pi, 5 pi. So the angles pi, 3 pi, 5 pi will give the same cosine, sine, and tan values. And similarly, for 270 degrees, it is going to be 3 pi by 2. So you add another pi. So it is going to be 5 pi by 2, so on. So please remember, we have a cycle of these angles, and we get the same values for the trigonometric ratios. In this lesson, we will explore one of the foundational concepts in trigonometry that frequently appears on the SAT, the unit circle. Our focus will be on understanding how angles, coordinate geometry, and trigonometric ratios come together in a single unified framework. The unit circle provides a precise visual representation of sine and cosine values, the relationship between degrees and radians, and the special angles that the SAT expects students to recognize quickly. Let us begin by establishing the key definitions and then gradually build towards the complete structure of the unit circle. Trigonometric ratios are calculated only on right angle triangles. In a right angle triangle, the sine of the angle is the opposite side divided by the hypotenuse. Similarly, cosine is the side adjacent to x degrees divided by the hypotenuse. Tan of the angle is opposite side divided by the adjacent. Now, the sign of these functions in the quadrant plane would be in the first quadrant, all are going to be positive. In the second quadrant, sine is only positive. In the third quadrant, tan only will be positive. And in the fourth quadrant, cosine would be positive. Now, to convert an angle from degrees to radians, we simply multiply the given angle by pi over 180. So 30 degrees will be equal to 30 times pi over 180. So we get pi over 6. Similarly, we could get all other degrees converted into radians or also sometimes the respective values. In that case, we'll apply pi equal to 22 by 7, or you can also apply the approximate value 3.14. Or in Desmos, you could simply type pi itself. And careful, before you measure the trigonometric ratios, you need to check if the settings has degrees or radians in it. Now, if you look here, tan 30 is 0.5 when it is 30 degrees. And when it is 30 radians, we have a different answer. So please be careful. Now let us solve a few examples. In this diagram, the angle is 23 degrees. And now we need to find the vertical rise. So let this be x. And as x is opposite to 23 degrees, we can apply sine 23 degrees. That will be equal to x over 13. So x equals 13 times sine 23. So it will be option B. Similarly, to find cosine in the quadrant plane, first we need to complete the right triangle. So this is a right triangle with base 5 and height also 5, which we get from these coordinates. And to find the cosine, we also need to find the length of the hypotenuse. As this is a right angle isosceles triangle, you could apply the triplet 1:1:√2. So the hypotenuse is going to be 5 times √2. And now to find cosine, we do adjacent 5 divided by hypotenuse, which is 5√2. So we get 1 over √2. Again, option B. Now, sometimes, like we discussed in geometry, we have to imagine lines to solve the questions easily. So here we don't see a right triangle. So let us imagine a height from this vertex. So now we have two right triangles. And to find the measure of tan x, we need the adjacent and opposite. So adjacent would be half of 80. So now we need to find the opposite. So let us apply the Pythagoras theorem. So 41 square equals 40 square plus the opposite side square. Do this in Desmos and we get the opposite as equals 9. Hence, the value of tan x is going to be opposite over adjacent. So that will be 9 over 40. You could also convert it into decimal, and the decimal answer must contain 4 significant digits. The unit circle is a circle with center as origin and radius of 1 unit. Now here again, we need to imagine the right triangle to solve the questions on unit circle. All we need to do is draw the right triangle. Let us solve an example.